Hello, Math 30-2 students. We're looking at lesson 6.1 and 6.2, characteristics of an exponential function. So in example number 1, what I want to do is show you what an exponential function looks like and how to graph it, and then look at different kind of characteristics of it. So that's what's important in this lesson. So in example 1, we're just picking out which ones are exponential. So the only one, so exponential are graphs that rise or fall very quickly. So those represent population growth or anything that grows or falls very quickly. So the ones that are exponential are these two. So this one's an increasing exponential, and this one is a decreasing exponential function. This guy is linear, so that's something that we looked at in 10C. This one is our next unit, and this one is called a cubic function. This one's quadratic, and this one's also quadratic. Okay, so right now we're looking at B and E. Those are the only exponential ones. So what we'll figure out is why is one increasing and why is one decreasing. So in example number 2, what we're going to do is graph each one of these, and I'll show you what buttons I'm pressing. So you want to figure out what the x-intercept is, the y-intercept, the end behavior, the domain and range of each function, and decide and whether it's increasing or decreasing. Okay, so I'm going to go to the graphing calculator, and I'm going to put in 8 3/4 to the power of x. Okay, so I'm going to use the standard window, -10, +10, -10, and +10. The scales should be 1. So I'm graphing it, and then I get something like this. Okay, so this is a, if you look, it's going down to the right. So it starts off high and then goes down. So we're going to sketch what this looks like. But what I also want to do is I want to find out what the y-intercept is as I look at it. So I'm going to go trace 0, enter. So in your calculator, you guys should be putting in trace 0, enter. For me, I'm going to have to do second trace, and then I'm going to have to do value, and then I'm going to put 0, enter. So my y-intercept would be 8. I'm going to sketch that as well over here. So I know that the value is 8 and it's doing something like that. So you're going to have arrows on either side. This is the x-coordinate or the x-axis. That's the y-axis. So you'll notice that the 8 matches this. This is actually your y-intercept, and this is called your base. So the value that comes directly in front of your base is your y-intercept. So here in B, that's my y-intercept. My y-intercept is 10. This one, the base is E, so the value right in front of it, even if you don't see it, is a 1. So my y-intercept is 1. Now I'm going to go back to the graphing calculator just to show you something. Now if I try to extend this graph by changing the x max to be 100 and graph it, you're going to notice that if I keep going to the right, the value is never going to become negative. The reason being is that the graph should never cross the x-axis when it's exponential for you guys. So what you'll notice is that there are no x-intercepts for any of them. So we found the y-intercept, we found the x-intercepts. Now the end behavior. The end behavior is where the graph starts and what quadrant does it start in and what quadrant does it end in. When we label our graph, we always label it as this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. We always label our graph from left to right. So that means that the graph starts in quadrant 2 in Roman numerals, and it goes to quadrant number 1. So that's what should happen for all of these graphs. It should always start in quadrant 2 in exponentials and go to quadrant 1. So that would be the end behavior. The domain for all of these will be that x such that x is an element of real numbers, meaning that the graph extends forever to the left and goes forever to the right. So that's XER. X can be anything. The range will be that y such that, we'll say y has to be greater than 0, meaning the graph is above 0, so it's going to be positive. Okay, so it's not going to equal 0, it's going to be above 0. So that's going to be y is greater than 0, YER. So that's the proper way of writing your domain and your range. And since it's going down to the right, this is going to be a decreasing function. And the reason I know that is because the base is a value between 0 and 1. So if our base is between 0 and 1, meaning it's a decimal value or a fraction, so it's less than 1 but positive, it's going to be decreasing. So I'm going to graph the next one, 10 times 2 to the power of x. So what you'll notice is that this one is increasing. And if I go second trace number 1, or you guys will go trace 0, enter. When I go trace 0, enter, I find that the y-intercept is 10, which we already talked about that. That is our y-intercept is 10. There are no x-intercepts, and I'm also going to sketch it. So I know that the value is going to go through 10. So you should always have arrows on either side to show that it continues forever left and forever right. So the end behavior is still going from quadrant 2 to quadrant 1. That's not going to change. So it's going from quadrant 2 to quadrant 1. The domain is not going to change. It's going to be the same. So we'll say x such that x is an element of the real numbers for your domain. And for your range, you're going to say y such that y is also greater than 0, YER. And this is an increasing graph. And the reason I know that is because the base, which is 2, is greater than 1. So if the base is higher than 1, you're going to find that it's an increasing function. Our next one is like a strange one. Now this E value is called Euler's number. That's a number that's like 2.7 something. It's a number like pi that goes on forever. So we're going to find that in our calculator. So the E is just right above ln. So if you guys look on your calculator, the bottom left, it says ln. Just above that, see, so I'm pressing ln right now. This guy right there. If you guys look in the fine print, that like shift, you'd have to press shift and then, or second and then ln. You're going to get e to the power of, and you're going to put power of x. Then you're going to graph it. You're going to see that it's an exponential function that is increasing. It's going up to the right. So I'm going to sketch what that looks like. Now the y-intercept is 1 because there's no value in front of e to the power of x. There's no x-intercept. We know the quadrant's going from 2, the end behavior is going from 2 to 1. As usual, the domain is x such that x is an element of the real numbers. Range, y such that y is greater than 0, YER. And it is increasing, because Euler's number, meaning E, is higher than 1. Example number 4, we are just matching which equations match the graph. So what I would do right here is to practice. You should pause the video and then see if you get the same answers as me. So right now I'm going to give you the answers, but you should have paused and tried this by yourself before seeing my answers. So what we're looking at is what can help us is the y-intercept. This is the y-intercept, the value in front of your base. This is your y-intercept. So the y-intercept here is 1, and the y-intercept here is 1. So we'll leave that to the end. But for 2 and 3, we can look at the y-intercept being a third. So the y-intercept of a third looks like it's C, letter C. So that has to be I then. And then the y-intercept of 3 looks like it's D. So that would be I. And then between 1 and 4, we know that it's increasing versus the other one is decreasing. So it's increasing because the base is greater than 1. So that has to be then 1i. And our 4 has to be the first one because it's decreasing. And that's it. So our last example here for this one, we're just going through the characteristics of these two graphs and saying what's the same, what's different. So what we want to do is determine the y-intercept, domain, and range of each function. So let's start with student A. We're talking about caffeine levels and how our body absorbs caffeine over an 8-hour period. So for the first one, student A, we're going to divide it student A, and this will be student B. The y-intercept is equal to where it starts, which is 80, and that's going to be milligrams, versus the y-intercept here is 100 milligrams. The domain is going to go from, well, we don't know where it's going to end, so right now I'm just going to say where, so it's going to be slightly different because this is a real life scenario. So we're going to say x such that x is greater than and equal to 0. So when time is 0, hours is 0, that's when we start. Okay, we don't know how long it's going to continue on, so that's why I'm just saying greater than or equal to 0. It's going to be the same for this one as well. Domain will also be x such that x is greater than or equal to 0, xer. Our range for this guy will be from y is greater than 0 but less than 80. So we're going to say greater than 0 but less than and equal to 80. The reason I'm saying it's going to be equal to 80 is because it actually touches 80. We start off with 80 milligrams of caffeine and then it goes to 0, but we don't know when. So that's why we're saying it's going to go greater than 0 but not necessarily touch it from what we see. And then our range for this one, we should always say this y such that and yer at the end, just for proper notation. Here we're going to say y such that y is greater than 0 but less than equal to 100 milligrams, yer. Okay, so that's your proper range. Why are both functions decreasing? It's because their bodies are absorbing, their bodies are metabolizing the caffeine, which means that the caffeine level should go down when your body, when it goes through the body. Based on the graph, which student consumed more caffeine? Well, more caffeine would be student B. Which student's body processed the caffeine more quickly? Well, also student B. The reason being is that when we look at their times at about 8 hours, it looks like student B actually has less caffeine than student A. So the person is processing the caffeine more quickly. Estimate the amount of caffeine in each person's body 4 hours after consumption. So we're going to look at the graph and extend it and say, okay, this one looks like student A looks like he probably had 20 milligrams. And then student B, if you look at 4, looks like they're probably about approximately 18 milligrams. So this is just an estimation. We're just using the graphs to figure out our answer. And then our y-intercept. The y-intercept is where the graph starts. So we know that the student A starts at 80 milligram, and what that means is that they had 80 milligrams of caffeine in their energy drink. And student B, why are they different? Well, because he drank a different energy drink. And this energy drink had 100 milligrams of caffeine in the actual bottle. Okay, so that's it for lesson 6.1 and 6.2. So those are the characteristics that you want to kind of look over. So what you need to take from this lesson is that you need to be able to find the y-intercept, the x-intercepts, that there's none for these ones, the domain, range, the end behavior, and then apply that to real life scenarios. Okay, thanks guys for listening.